Now we're going to solve a few more op-amps. Right here we have a non-inverting amplifier. That just means we're going to have some signal Vn right here going through, and it may look like this. What's going to happen is our signal is going to be the exact same, but it may be amplified a little bit, or it could be, de-amplified based on what the resistors are. And we're going to go ahead and solve that. And first off, we need to note that we actually have a voltage source right here on the positive side. And because we have a resistor right here, we know that there is also going to be voltage right there. And that means that our voltage positive is going to be equal to voltage negative, and which is going to be equal to our voltage coming in. And now all we have to do is do a Kirchhoff's node law right there, or current law, just like we did in the previous circuit right there. And that is going to be the same thing, which will look like this. We have 0 minus the voltage at the negative part, so the voltage drop between that resistor divided by that resistance is going to be equal to voltage the negative minus the voltage out, so this voltage drop right there divided by that resistance. And if we take that and solve for V out, we will get something like this. Vn times 1 plus R2 divided by R1. So if R2 is, let's say it's a big resistor right there, it's going to cause more flow to go through the op-amp and become amplified. So if R2 is big, then our voltage out will be more amplified. You'll get a larger signal. However, if R2 is really small, then we will become more just like what we already are, and our signal will not be amplified that greatly. So now coming down to the inverting summer op-amp circuit. This looks really scary, but it is basically the same as the first op-amp circuit we did. This one, the inverting amplifier, except all we have now is two voltage sources right there and right there. What this does is it takes these two signals. One could look like this, the other could look like this, and they will add them together and invert them. So if we follow along, we'll have mutual resistor right there and a resistor right there. Come to here, and at that point we are at V negative. This at V positive is 0, so that means that our V negative is equal to V positive, which is equal to 0. So we know that we have 0 voltage right there. And the current will come through these resistors and eventually make it out. And so now all we have to do is one big Kirchhoff's node law at that node. Now we have three currents to worry about. We have the current coming through here, through there, and the current coming through there. And so we're going to start off with the first resistor. We're going to have the voltage source 1 minus our negative voltage source right there, which is 0, all divided by that resistance. So again, we have a voltage drop around that resistor, Then we're going to add that to this current because they're going in the same direction, which is going to be V2 minus V negative all over second resistor. And that is going to be equal to V negative minus our V out all divided by that third resistor. And once we solve for V out, that'll look something like this. V out is equal to negative R3. Remember, it inverts the signal, times V1 over R1 plus V2 over R2. Now our R3 is where we get the amplification. If R3 is high, then we will be more amplified. If R1 or R2 are high, then we will be not as amplified. And they will, if they are not the same, then they will bias one of these voltage signals and cause one of them to become greater than the other than they used to be. The last one we want to go through is the subtractor. And here we have two voltage sources again, except one is going to the positive and the other is going through the negative. And there's going to be a feedback control right there. And so now we know that V minus is equal to V positive, and it is not going to be equal to 0 because we have this resistor right there, and there needs to be a voltage drop to get to ground. And we're going to have to use two Kirchhoff's node laws at those two nodes, summing the currents and setting them equal to each other. So we'll start with the first voltage source, which is going to look like V1 is equal to, V1 minus our V negative divided by our R1 is going to be equal to our V negative minus our V out divided by our second resistor. And on this node, you'll have very similar V2 minus V positive divided by R2 is going to be equal to our V positive divided by our RF. And if these two resistances, this is RF right there. There we go, catching on. Alright, if these two resistors are equal to each other, and we take these two equations and combine them and solve for V out, you'll get something that looks like this. RF divided by R times V2 minus V1. And you can see that this circuit will take these two voltage signals right here, right there, and they will subtract them and then amplify them. And that is the purpose of that op-amp.